Hello, everyone. Welcome to this virtual PSA 2020 annual meeting. My name is Dinabandu Jordar, presenting abstract number 238, and the title of my presentation is Effect of Dietary Limestone Particle Size and Potassium on Life Performance and Blood Physiology of Male Broiler Chickens. Blood biochemical parameters such as pH, partial pressure of carbon dioxide, bicarbonate, and base excess are the primary parameters associated with blood acid-base balance regulation. Blood buffer pairs follow the changes in partial pressure of carbon dioxide, and fast-growing broilers are known to increase hydrogen ion concentration. Effects of limestone particle size on performance, calcium, and phosphorus utilization has garnered much interest in the broiler nutrition. However, there is lack of information on blood gas parameters affected by dietary limestone particle size. Potassium provides electrolyte balance between cations and anions, and the blood potassium levels can be altered by release of stored potassium from the ICF, which is the intracellular fluid. Potassium is alkalogenic in nature, affects blood pH, and potassium affects blood gas parameters. Role of potassium has been explored in muscle myopathies in some recent work done in our lab. Thus, a study was designed to investigate the effects of dietary limestone particle size and its interaction with potassium supplementation in broiler chickens. Coming to materials and methods, 384 Ross male broilers were placed in 24 floor pens and were fed 4 dietary treatments. Each dietary treatment had 6 replicate pens, having 16 birds per pen. The feeding phases were starter 0 to 16 day and grower 17 to 35 days, containing 2 limestone particle sizes, fine and coarse, and were amended with either 0% basal potassium, denoted as K-, or 0.2% added dietary potassium, denoted as K+, with potassium carbonate, to complete a 2x2 factorial arrangement. Here's a picture of our limestone particle sizes. On the left is a fine limestone particle size, and on the right was coarse limestone particle size. Moving on to the nutrient composition of the experimental diets. The diets were formulated to be isocaloric and isonitrogenous, and either met or exceeded the NRC 1994. The dietary sodium and chloride levels were formulated to be constant. The 0.2% potassium carbonate supplementation achieved potassium levels of 1.03% and 0.92% in starter and grower, respectively. Also, the potassium carbonate supplementation increased the dietary electrolyte balance in K+ diet, both in starter and grower phases. Body weight and feed intake at 0, 16, and 33 day were measured. FCR included body weight of mortality. Blood physiology parameters at 35 days were packed cell volume, hemoglobin, ionized calcium, glucose, sodium, potassium, pH, total carbon dioxide, partial pressure of carbon dioxide, bicarbonate, base excess, partial pressure of oxygen, and oxygen saturation of hemoglobin were measured. Carcass measurements were done at 35 day for wooden breast and white striping scores. Statistical analysis. Data were analyzed as a completely randomized block design in a 2x2 factorial arrangement with the following notation, where I, J, K are indices for limestone particle size, potassium, and block as a random effect, respectively. The data was analyzed using fit model platform of JUMP 13.2. P-value less than or equal to 0.05 was considered significant, and the LS means were separated using students' t-test. Moving on to our results and discussion. There were no two-way interaction found. However, some trends were observed. Therefore, the main effects are discussed first. K+ dietary treatment reduced feed intake by 3.5%, and the body weight gain was reduced by 4%. in the starter phase, 0 to 16 day. However, there was no effect on FCR during the starter phase. Similarly, during the overall period of 1 to 33 day, the K plus dietary treatment reduced the feed intake and body weight gain by 3%. However, there was no effect on FCR during the overall period. Summarizing the live performance, the present findings were in agreement with Teeter and Smith, who observed reduced body weight gain with addition of 0.15% potassium carbonate and associated the response to reduced water intake. In the current study, the responses may be attributed to the potassium carbonate dosage rather than only a response to increased DEB or altered potassium levels per se. However, we did not measure water intake in the current study. Moving on to the blood physiology results that were measured by an handheld iStat instrument. There were no effect of limestone particle size on blood physiology assessed. The effects of potassium on blood physiological parameters are discussed in the following slides. K plus decreased blood glucose and also decreased the blood sodium, which is indicative of a lower ECF volume. So now taken together the sodium and the glucose parameters, it suggested that alterations were found in the metabolic activity from the sodium role in glucose absorption, which may have been partially induced by the reduced feed intake and growth when K plus diets were fed. Moving on to the acid-base parameters, the K plus decreased ionized calcium, and the mechanisms are unknown here. K plus exhibited decrease in total blood carbon dioxide and also decreased blood bicarbonate and base excess. This could be partially explained by the interaction trend observed on partial pressure of carbon dioxide. The K plus did not increase the partial pressure of carbon dioxide when compared with K minus, which exhibited elevated partial pressure of carbon dioxide required for compensation of the elevated bicarbonate, which was coming from the K minus diets. Further, the correlation between blood partial pressure of carbon dioxide and blood bicarbonate showed that in a bivariate correlation that partial pressure increases to compensate for the elevated bicarbonate. The elevated bicarbonate could be explained by this data on interaction between limestone and potassium on blood pH parameter, where pH was trending to decrease with feeding of coarse limestone diets. And the bivariate correlation between blood pH and partial pressure of carbon dioxide concentration partially explains that a decrease in pH will stimulate pulmonary ventilation by elevating partial pressure of carbon dioxide. Thus, combining the correlation data, and expectedly, it demonstrated that blood buffer pairs move in unison, and the changes were induced in the partial pressure of carbon dioxide as a compensatory mechanism, which were governed by this isohydric principle. The blood biochemical parameters, pH, partial pressure of carbon dioxide, bicarbonate, are the primary parameters associated with blood acid-base balance regulation, hence could be used in the physiological assessment with using iStat instrument. In this experiment, blood chloride was not measured, and it is indeed an important measurement as it is involved in physiological regulation of blood gas acid base. Hence, monitoring of chloride would have made a more powerful argument in this experiment. Thus, for conclusion, there were no effect of limestone particle size on live performance and blood physiological parameters assessed. Birds fed K plus dietary treatment returned a decreased feed intake when compared to K minus diets during the starter and grower. The venous blood parameters assessed were found consistent within the physiological homeostatic range, which was indicated by the correlation between pH, partial pressure of carbon dioxide, and bicarbonate, the primary indicators of acid-base status. Supplementation of Potassium may influence the buffering capacity, even though the venous blood parameters assessed were found within the physiological homeostatic range. However, further studies are required to assess the dose response of dietary levels of potassium carbonate that may be beneficial for live performance and acid base homeostasis. With that, I end my presentation. Thank you all for your attention, and I will take any questions now. Thank you.